Hi everybody, in this video we are going to discuss about how to insert a node in a circular linked list in the beginning, right? So let us consider a circular linked list with 5 nodes like this, and this is the new node that has to be attached to this circular linked list. So what are the changes that we have to make? We have to do 3 things. First thing is we have to make a connection between the new node and the current first node of the linked list, because this new node will become the first node hereafter, and this should become the second node. This change we have to make. And the next change what we have to make is we have to establish a connection between the last node's next part and this new node, because as per the concept, the next node's last node's next part should contain the address of the first node. So this connection has to be made, and then we have to move the head from the previous first node to the current new first node, right? These 3 changes we have to make, and just 3 things are there. Actually the order of doing is also very important, right? That is, I am telling that this is first, but this can be changed at any point, but let us assume that I am going to do this first. I have to do actually the changing of the next part of last node to the first node before moving the head. Why? Because how will I identify the last node? I have to have a temporary pointer. Let us have a temporary pointer, and what I can do is I will be traversing till the next part of the node is equal to head. That is the current list head. Okay, before inserting the new node, whichever is the head, right, whichever is the first node, that address only will be in the last node. So order is very important. Suppose if I am going to move the head before I move to the last node, then I will be in trouble. My temporary pointer will be moving on an infinite loop. I hope my point is clear. I have to first of all declare a temporary pointer and then initialize that to the head of the node, head of the list, and I have to move it to the last node, because in circular linked list how we can identify the last node is the next part of the last node will be equal to head, right? That is the current first node. If I am moving the head before that, suppose if I tell head equal to new node, then I will be on an infinite loop, because none of these nodes in the circular linked list is having the address of the new node, isn't it? So the order is very important, and let us formulate the algorithm. Step number 1 is we are going to call the create node function and get the address returned in the new node, right? And then you are checking whether new node is null. If it is null, then we will return false. Otherwise you have to do one thing. Actually there is one exceptional cases. Let me tell that if the list is empty, okay, if the list is empty, it means that head is equal to null. That is the condition. We tell that the list is empty, right? In that case, what we will do, we will create a new node, put the data in the data part. For example, if 5 is the data, put the data in the data part, and you will make head to point to this. One more thing that what we have to do, as per the concept, the next part of the last node should contain the address of the first node, right? When there is only one node in the list, this is the first node and this is the last node as well, okay? So the next part of the node should contain the address of itself, right? This we shall have to make. So this is an exceptional case. So when we are writing the algorithm, we are writing it in a separate case, right? If list is empty, then you make next part of the new node to hold the address of itself, and you make head to point to the new node and return true. That's all done. Otherwise what you have to do, now you have to make the next part of the new node to store the head, right? I have made this particular change, right? I am making this particular change as I told you. This one will be first done, and second one will be locating the last node and making it to point the new node. That's what we are going to make. So for that what we do, we declare it a temporary pointer temp, and we move temp to the last node, and then you will make the next part of the last node to have the address of the new node, right? Okay, it should contain the address of the new node, not first node, and then you make head to point to the new node. This algorithm should help us to make insertion at the beginning. Let us write the code for this in C. and you can see that in the header file we have got the declaration. The return type is int. Actually it is going to return true or false. Since C does not support bool, I have given the return type as int. Whether the insertion is successful or not will be communicated after the operation. And you see here we have got the list, and it is passed by reference and the data. Okay, so let us write it int and then insert beginning. You have to pass the list by address because we have to make changes, and that should get reflected, right? And the data that should be inserted is also coming in. Now first thing is we have to call the create node function. Okay, so let me declare the things. I have to traverse also, so I have declared 2 pointers, and then let us tell new node equal to create node, right? And you pass the data to the create node function, right? Done. So the node is created, and you have to check whether the value returned is null. Okay, so either you can tell new node equal to null or not new node, because as we discussed earlier, null is false in C, right? So we can do like that. If new node is equal to null, then what we can do, we have to just return null, right? Sorry, we have to return 0, that is failure. Otherwise what we can do, if the list is empty, right, this is a case that we have to consider, is empty of, actually is empty expects you to pass the list by value. Now in L we have got the address, so you just put a dereferencing operator and then you tell, right? Yeah, in this what we have to do, we have to do 2 things. One is you have to make the next part of the new node to hold the address of itself, right? So new node, okay, next is equal to new node, right? That's what the algorithm tells, and you make head to point to the new node and you have to return true. Okay, so head equal to new node, right? And then you'll be returning 1 to return the true. Okay, it is successful. And otherwise you will be going to the next step where the next part of the new node will have address. Okay, sorry, you have to create a temporary pointer. Okay, you have to create a temporary pointer and then we have to move. This is done, right? I think one extra step is there. We will make the temporary pointer. Okay, before that, before that you have to make the next part of the new node. That is, this is step number 1. That's what is given as step number 4 here, right? So I have to tell new node next is equal to head, right? This I can do even as the last step, no harm, because this is totally independent, but I should not move the head before I identify the last node. In a circular linked list, we can identify the last node with the address of the first node only, so we should not lose it. We should not move the head before I locate the last node, right? And then what I am going to do now, temp is equal to L head, right? You make a temporary pointer, make it to point to the first node, and then you move to the last node. How will I know the last node? The next part of the temp will be equal to null. So let me tell, while temp next not equal to null, I am going to move the temporary pointer. Okay, so temp equal to temp next, right? I have to move till the last one, right? So I am telling while temp next, sorry, no, not equal to null, sorry, this is for normal single linked list, this is circular linked list. So we have to tell while temp next not equal to L head, right? So we will be doing things and we will be moving till the last node by using this condition, temp next not equal to L head. So after I go to the last node, what should I do? I should make the next part of the last node to point to the new, right? So temp next is equal to new node. I have to tell this, and then I have to make head to point to the new node, right? So L head equal to new, node, and then you can return 1, right, to indicate success. Okay, so I hope this is done. But I need a print function to check whether this is working properly or not. So we will discuss the print list function, we will implement, and then we will check this insert beginning function, right? So how will we print a list? If you have got a circular linked list like this, what can be the algorithm? You have to have a temporary pointer, right? And you'll be printing the, you'll be making it a point to the first node, that is done. And then you'll be printing the data part of the first node, and then you'll be moving to the next node, and so on, right? So how far you'll be moving your temporary pointer is till you reach the last node, right? So I'll be telling that while I am not in the last node, you print the data, right? That's what I'll be telling. And so I will not be able to, when I write the loop, you will understand, I will not be able to print the last node's value. So I may have to write it separately. That is there. But what about the case when my list is empty, right? When my list is going to be empty, how can I know that, right? If the list is empty, then you have to return immediately, right? So you have a check in the beginning itself whether the list is empty, right? Because I will be checking whether temp next not equal to null, like that, not equal to head, right? That condition will be checking. So if it is a null pointer, I may get an error. It's better to check whether the list is empty in the beginning of the print function and immediately return if it is empty. Otherwise we will proceed, right? So if the list is empty, so the algorithm will be like this. If the list is empty, then we have to immediately return. Otherwise declare a temporary pointer and make it to point to the head. While temp is not in the last node, you have to repeat 4 and 5. You print the data part of the temp and move temp to the next node. So what will happen? Actually we are doing these two steps while temp not in the last node. So I have to, but when I am printing, I have to print the last node also, isn't it? So in step number 5, sorry, this should be step number 6. In step number 6, we should tell print the data part of the last node and you return. Okay, this is required because we are having a loop in which we are checking while we are not in the last node. While we are not in the last node, you are printing the data and you are moving to the next node, right? So after coming out, I will be, my temp will be in the last node and its data was not printed, so I have to print it. This step is also required. Let us implement this and see. Okay, so my void print list, right? And the list is going to come by value. Okay, and let us have a printf statement to indicate that list is getting printed. Okay, list is printed, you can tell, and \n. Okay, and here I am going to tell node star temp equal to l.head. I make temp to point to the first node, and then I'll be telling while temp next, right? While temp next not equal to null. What should I do? I should print the data, right? How will I print? %d \n, and then I'll be telling temp data, right? I'll be printing the data part and then I'll be moving to the next node, temp next. And after I come out, I should also print the last node as we discussed. So we should have a printf, okay, and %d \n. I will be telling temp next. Okay, so hope this will help us. And the application is looking like this. First I am checking whether the list is empty. As we discussed in the previous video, a garbage value will be there in the head, so our isEmpty function will return false. It will tell that the list is not empty, but that is not correct. This is just for understanding. And then we are calling the create list function. In the create list function, we are initializing the head. Okay, we are initializing the head is equal to null. So after that, if I check whether the list is empty, it will tell true. Okay, and then I am calling the insert beginning function. I am trying to insert 1, and then I call the print list function. So the print list function should print 1. This is what is expected. Let us compile the code and check it. Yes, when I compile, I get 2 errors. The first error is in line number 44. Here I have given as head. It should be L head, right? That is the mistake. And next one is in 61, when I am printing, I have made a mistake. I have given, while printing, I should print the data part, isn't it? So this is another one mistake. Okay. So I'll be compiling again. So we compile the circular linked list file, right? And I do redirect the output into cll.o. Yes, compile successfully. Next we will compile the application file, and only compilation -c is the option for that, and it is redirect to cll.a, right? That's also fine. Then we'll be compiling, now you will invoke the linker by using the GCC, right? Yeah, that's also done. Let us try executing it, but it's going on an infinite loop. Let us find the reason for that, why it is going on an infinite loop. It's obvious. I have given while temp next not equal to null, it should be not equal to l.head, right? It's a circular linked list. I have given the condition as it is for normal single linked list. Okay, that's the mistake. So let us compile first this and put it there, and then GCC application, and then -c -o cll.a.o. Okay, GCC cll.o cll.a.o. Okay, let us try it now. Yes, we have got 1. Fine. Now let us try to insert one more file. Now I am giving 2, right? So first we should compile this file, and then application file, and then I should link these 2 files, and then a.out, right? Now we are saying 2 1 because we are doing insert beginning. 2 will come before 1, right? Let me change this command to normal, so it should print 3 2 1, and now we are making changes only in the application file. So it is enough you compile only the application file, you use the same O file, object file of the file functions, that's fine. Okay, cll.c, we need not compile it again, and you will see that 3 2 1. Let me uncomment this 4 also. Now also we will compile only this, and then link both the object files, and then you try executing as 4 3 2 1, right? So this is how we will be working on with the circular linked list. The code will be shared, you can check it. Thank you.